So why do substances have different physical profiles? How come we can use this to uniquely identify them? Well, it all comes down to the fact that each substance is made up of different things. They have different types of particles making them up, and they are organized in different ways with those particles, and all of that affects how they behave. So the very first thing you have to think of is whether or not you're dealing with a pure substance or a mixture. In real life, most of the time, we're actually dealing with mixtures, not pure substances. So that always makes it a little bit more difficult, but it also means that we're able to get that mixture. Think of it as a recipe, and each recipe is unique. And because of that, if we can figure out the recipe of that mixture, the proportion of all of the different ingredients, then we can actually narrow down where that mixture came from, and I link it to a crime scene. It's just like every different type of baker has a slightly different recipe for their chocolate cake. So even if you had chocolate cake at a crime scene and you're looking at different chocolate cakes at all the bakeries around, every single one of those cakes would be slightly different. And it's that unique recipe or mixture that will help us to link it to the correct place. If it's a pure substance, it becomes even easier, but you'll find that out while we're doing our tests. Now, whether it's pure substance or mixture, you're going to be learning about the fact that each one of these are made up of different types of particles. Okay? It comes down to the different types of atoms that actually come together to make a substance, and how those atoms are organized. That affects how they behave as well. Whether they're tightly bound together or whether they just sit around together but they're not locked together, all of that organization affects how easily they will move apart from each other, come together, hold together when you heat them up. The organization is really important, so you're going to be learning about that as we get into our chemistry. But let's just go now and just start applying this basic learning to the physical property profile. So remember when I said there were different types of particles that make up substances? Well, the first thing you need to remember is that they fall into two main categories: metals and non-metals. Metals are usually shiny or can be shined. They do go dull after a while. At room temperature, they're solid, which means they have quite a high melting point and boiling point. Their melting point's going to be above, say, 30 or 40 degrees Celsius. They're good conductors of heat and electricity. They are malleable, which means that we can bend them and not break them, and we can even hammer them into sheets. And they're ductile, which means that we can stretch them out and turn them into wire and they won't break. Now, non-metals pretty much are the opposite of that. They're dull. They are usually a solid or a gas at room temperature. So some non-metals will be solid, but a lot of them will actually already have melted to a liquid and then evaporated into a gas before you get to, say, 25 degrees Celsius. Most of them are insulators, which means they do not conduct heat and electricity. They actually stop it from transferring through it. And they're brittle. They break or they crumble when you try to bend them or stretch them. So that's one basic physical property profile that you're going to have that's going to match most metals and non-metals. Even if you can't identify it perfectly, you can usually figure out whether or not you're dealing with a metal or a non-metal, as long as it's a pure substance.